Hi everyone. In this video, I'm going to recap on the mutex behavior that we saw in class. All right. So in the labs manuals last section, we were told to comment off the osMutexAcquire release, correct? And if we compile this code and we download this, okay. So let me execute it. So in this code, okay, you can see that basically what we have is we have created two LED threads, red and green. We have also created a mutex, okay, and then the LED red thread is acquiring the mutex, okay, and then releasing it, okay, and between that it is blinking the LED. For the LED green thread, it is acquiring the mutex, but it does not release it. All right, and we saw that in this case the behavior is the red LED blinks once, then the green LED, and after that there is no more LED activity at all. All right, and the main reason for this is once I finish this for loop and I come back to the beginning, I try to acquire the mutex again. Okay, so the thing we must understand is you can think of mutex as a binary logic. Okay, when I create the mutex, okay, it is originally having a value of 1. Okay, the moment I try to acquire it, the value becomes 0. All right, so right now when I try to acquire it again, the value is 0. All right, and in this case it will go into a block state. Okay, the thinking that I already have the mutex, or this thread is the one that actually is holding on to the mutex, so it should allow it to carry on. It is natural for us to think like that, but the way the OS operates is whenever you execute this osMutexAcquire function, it will try to acquire the mutex. That means it will try to decrement the value. Okay, so if the value is 1, okay, which is the original value, it will be able to decrement it and you will get a value of 0, which means you get the mutex. But if the mutex has already been obtained, then the value of mutex is 0. So when it tries to decrement it, you will not be able to do it, and so it goes into a block state. Okay, so think of the mutex as a form of a binary logic, okay, 1 or 0, okay, whether it is available or not available. All right, now in the RTX RTOS itself, okay, for mutex there is actually an option that can change this behavior. Okay, so let me bring up the documentation here. So over here, okay, when we create OS mutex, when we call OS mutex new, okay, we can actually pass in a parameter. Currently, if you look at the code, we have passed in the parameter of null, okay, which is basically means we are using the default parameters or settings for the mutex. Okay, but in terms of the attributes, there is one attribute called osMutexRecursive. Recursive. Okay, so if you look at osMutexRecursive, Recursive, okay, what it tells us is that the same thread can consume a mutex multiple times without locking itself. Okay, so I will be able to keep on calling MutexAcquire, okay, without locking myself. All right, even though it has already been acquired before. All right, so let's see that in action now. So the same thing right now, what I've done is at the top here, I've created a attribute for mutex, all right, and I have put the parameter here as os mutex recursive. Okay, and what I'm going to do is in the os mutex new function, instead of now, I'm going to call this I'll pass in this parameter here, thread mutex attribute. Okay, so what will happen is when I create the mutex now, I'm passing in this attributes, so it will have the attributes as being recursive. Okay, that means the same thread can call itself again and again. Okay, whichever thread has the mutex. So let's see this in action now. So if I build this code right now, okay, and I run it, okay, so when you're watching the video, just stop for a while and just think what would happen. All right, and then you carry on playing. Okay, so let me run the code now. So the red LED blinks, then the green LED, and then the green LED continues blinking. Okay, so as you can see, Why is this the case? Because in this case here, with this modified attributes, I have allowed the recursive mutex acquire feature, which means that the LED green thread can continue to acquire itself the mutex that it already has. Okay, the LED red is unable to carry on running because I never released the mutex. Okay, so the uh, LED red thread which had called the osMutexAcquire is already in the block state and will forever stay in the block state. Okay, because I have not released the mutex. Okay, but of course this sort of changes the whole behavior of how the mutex behaves. Or how the mutex is, or understanding of how the mutex is supposed to behave. Okay, important thing to note is, okay, if you look at the documentation here, the mutex must be released multiple times, okay, until the lock count reaches 0. Okay, so basically every time you are locking it, okay, you are sort of incrementing the lock count. Okay, and you need to keep on releasing the mutex that number of times, then only it goes back to 0, and then the uh, another thread can actually acquire it. Okay, so you need to be careful of using this recursive feature, all right, because if you use it wrongly, you can just sort of mess up, okay, the whole expectation of how the mutex is supposed to help you. Okay, so always think back that the mutex is supposed to help us to protect shared resources, all right. So that is why generally we do not use this recursive attribute, okay, but using this we can change the behavior. Okay, another thing that you may also have, another doubt you may have is, how do I modify the code such that if I do not want, okay, to uh, acquire the mutex but still be able to carry on doing other things. Okay, so let me modify the code here. So in this case, what I'm going to do is, okay, over here you can see that uh, I have modified the LED red thread, okay, where the osMutexAcquire, okay, I actually do two things. Firstly, I capture the return value. Okay, so let's look at the osMutexAcquire call over here. So you can see that it actually has a return value called os status t. All right, and this os status t basically will tell me whether it's successful or not. Okay, so if you look at os status t, okay, there can be a lot of different errors. We do not need to worry about all the errors. All we need to know is whether it was okay or not. If it was okay, means the operation completed successfully. If it was not okay, then it could be any of the errors. It could be any of the errors, so we do not need to go into the exact error. Okay, but what I want to show you is, I can use this return status to know whether the operation of the mutex acquire was successful, and then decide what to do or what not to do. Okay, so for example over here, I can choose to, okay, modify the code such that when I call osMutexAcquire, I check the my status, and if the my status is not okay, that means I did not acquire the mutex, then I can do something else. Okay, if I acquire the mutex, then I can just carry on blinking the red LED. If I did not acquire the mutex, then I can do something else. Okay, another important thing is that the timeout value, the second parameter here for osMutexAcquire, okay, if you notice in the earlier option, we used os wait forever. Os wait forever means we will wait as long as it takes until I am able to acquire the mutex. In the case of 0, which means I do not want to wait. If I try to acquire, okay, I will execute the osMutexAcquire function, and based on the return value, I will know whether I got it or not. So I will still be able to proceed with the code, except that now I need to have two options, correct? If I get the mutex, what do I do? If I don't get the mutex, what do I do? Okay, so let me show you this case. For example, instead of putting this empty, why don't I call the LED control function here? Okay, and I'm going to call blue LED on. Okay, so what is going to happen is, if I do not acquire the mutex, I'm going to switch on the blue LED. If I acquire the mutex, I'm going to blink the red LED. Okay, so let me bring up the code here and the board. Okay, so let's rebuild this code. and let me show you what I'm going to do here. Okay, so let me also remove the recursive never mind. Let me leave the recursive function. So basically from the recursive function, what we know is I will blink the red LED one time, and subsequently I will keep blinking the green LED. All right, so let's see what happens now. So let me go into debug. Okay, so now what is happened is in the red LED I have this option where I do not have to wait or go into a block state if I do not get the mutex. Okay, if I do not get the mutex, I will just control the blue LED. If I get the mutex, then I control the red LED. Okay, so let's run the code. So first is red LED, then green and blue and green. So what you see here is a turquoise color as well as blue. Okay, why you see the turquoise is because basically the blue LED is on forever. Alright, because basically once I do not acquire the mutex, the blue LED is it remains on, but the green LED is continuously blinking. So during the time when the green and blue are together, I get a turquoise color. Okay, other than that, I see the blue color. Okay, so you can see that there are different ways of changing the behavior of the mutex. Okay, I can use recursive function. All right, I can use the return value to uh, to decide whether to carry on or not to carry on. Okay, or have different options of carrying on the code. Okay, with or without the mutex. Okay, so all these are different ways in which you can actually change the behavior. What is important is when you are implementing these things in your code, you must be very clear on what you want to achieve. All right, and make sure that whatever attributes that you put in place or whatever code changes that you make reflect the objectives you want to fulfill. Okay, so I hope that this video gives you a better idea on the OS Mutex. Okay, uh, as always, please refer to the online documentation on the OS kernel core so you understand exactly how to use them in your code. All right, so thank you for watching. I will see you in the next class. Bye.